So this is going to be doing operations with functions, and the nice thing about this is most of the time it's just adding like terms and then plugging in your numbers, so it's not super difficult, but let's talk about a couple things. The first thing is that they like to write things a little bit weird, so they have f of x plus g of x. This part that I underlined in blue I feel is very straightforward, makes a lot of sense. But typically how the book will write it is like this. So it means the same thing. I don't want you guys to think that they are separate or that they mean different things. They mean the exact same thing. So I just want to make sure you understand and have that in your mind as you do your homework or as you do these problems. And so all they're asking you to do is to add the two functions with whatever like terms that you have. And then once you're done, they want you to evaluate it. And the evaluation comes from whatever they set to x. So in example 1.1a, and there's no like prior example of that, but in example 1.1a gives you f of x equals 3 times the square root of x, and then g of x equals negative 10 times the square root of x, and then they say x equals 4. And this is not how the book writes it. This is how I would like you to write it on your homework, so you can see each step separately, and hopefully that'll help you prevent any sort of mistakes or things like that. So we can go ahead and start this. All we need to do is just put these two together and put a plus sign between them. That's really all that's happening. So I have my first function, f of x, and then my second function, which is negative 10 times the square root of x. And so obviously we have this plus minus thing going on here, so we can just rewrite this as 3 times the square root of x minus 10 times the square root of x. And ask yourself, are these like terms? Well, yes, they are, because I have the square root of 10 for both of these. Now, if one had been like the square root of 10 and the other one was the cube root of 10, well, then no, they would not be the same, because you have to have the same variable, but you also have to have the same exponent. And technically, both of these have the exponent of 1/2. So that's what makes them like terms. So I can go ahead and combine this a little bit further. 3 minus 10 gives me negative 7 times the square root of 10. And so now that I'm done, this is one of my answers. This is the f plus g, my two functions added together. All right. After I'm done with that, they want me to plug in the 4 for the x here. So I'm just going to plug that in. That'll give me negative 7 times the square root of 4, which is going to be 2. And so therefore my answer is negative 7 times 2, which is negative 14. And so this is my final answer. All right, so it's not super difficult, but I feel like sometimes that there's a lot of things going on, so students get a little overwhelmed, or they'll get here and then they'll stop. So I just want to make sure that you remember to do all the pieces. So let's do another example. Example 1.1b says let f of x equal, and so this is how it looks in the book. It's all put together like this. So I recommend putting them separately so that you can see it a little bit easier. Obviously, you don't have to. The more you do this, the more likely you are to sort of just get used to the process, and you won't have to worry about it too much. The last sentence says evaluate f plus g of 8, okay? And so that's just another way to write that x equals 8. That's all that really means. So now that I've rewritten it, I'm going to go ahead and add the two. I say add f of x plus g of x. So my f of x was negative 2x to the 2/3 power plus 7x to the 2/3 power. Again, I have the same scenario before. I have the same variable with the same exponent, so I can add them. So if I add them together, it should be 5x to the 2/3 power. And then from here, I need to plug in the 8. Okay, so there's a couple ways you could do this. You could either do it in your head, or you can use a calculator. So you would type into the calculator just this portion right here, 8 to the 2/3 power. I'll give you a second to do that. And if you type into the calculator, please make sure that the 2/3 is completely in the numerator. Some calculators are not set to that, so you might need to use parentheses. But if it automatically goes everything into the numerator, or not numerator, but everything into the exponent, then you should be good to go. If you do that, you should end up with 8 8 to the 2/3 power is going to be 4, because really it's the cube root of 8, which is 2, and then 2 squared, which is 4. Or you just plug into the calculator. And then finally, 5 times 4 is going to be 20. And so that is our answer. So again, not super difficult. It's just knowing what to do with the pieces that you've got. And it tells you everything. It tells you what you need to be doing. Are you adding? Are you going to subtract? Are you going to multiply? And then what number are you going to use? All right, so addition, not terribly difficult. Let's try subtraction with example 2. All right, so let's look at example 2.1b. Because 2.1a is basically the same as before, but you're just going to have to subtract them, so make sure you do that correctly. So I'm going to go ahead and set this up. Again, it's on all together, so I'm going to separate it just a little bit because I am a visual person and I make mistakes if I do not write it out completely. All right, same thing again, evaluate when x equals 8, but this time I'm just subtracting. So I'm going to rewrite it like this. And then plug in my pieces. I got negative 2x to the 2/3 minus 7x to the 2/3 power. They're both subtracting here, so I would combine my my numbers with addition because same sign sum. This will give me negative 9x to the 2/3 power. And then again, I'm plugging in that 8. All right. We already figured out from the previous one that 8 to the 2/3 power is going to be 4, so it's going to be 9, or negative 9 times 4, which gives us the final answer of negative 36. All right, let's do one last subtraction one just so that we get used to it. Example 2.2c is a little bit longer, but I just wanted to show this process just to make sure that we are good. I'm not going to write them separately so that we can expedite this. I'm just going to go ahead and rewrite it as f of x minus g of x, and then I'm going to plug in the pieces I have. I have, for f of x, 6x minus 4x squared minus 7x cubed. And I just want to point out, this is not in standard form being from the biggest exponent to the smallest exponent. So we are going to have to fix that at the end. And this time, because I have a lot of terms going on, I'm actually going to use parentheses for everything. So this piece represents my f of x portion. All right, minus, and then I'm going to put parentheses again. Now I'm going to put in my whole g of x, which is 9x to the 5th minus 5x, and parenthesis, and let's get rid of this. And now I have a similar situation to chapter 4. So I'm going to take this and I'm going to distribute this. And I'm going to get 6x minus 4x squared minus 7x cubed minus 9x to the 5th. And remember, this minus sign has to distribute to everything, including that negative 5 at the end. 2 negatives make positive, which gives us a positive 5x. Now that I'm here, I'm going to combine my like terms. I got, this is a terrible 6. There we go. It's still terrible, but whatever. So I have my like terms with my 6 and my 5x, so that's going to give me 11x, and I used it, so I'm going to cross it out. I don't have any like terms with my 4x squared, so I'm going to just carry it down. I don't have any like terms with my negative 7x cubed, carry it down, and I don't have anything for my x to the 5th. Oops, wrong one. That's funny. Okay. So this is my combined function, but now I need to plug in a number. And so I go back to my original problem. It says then evaluate after you combine it. They want you to evaluate at -1. So you can literally just use a calculator. So I guess you don't have to put it in standard form. No, you should definitely put it in standard form because I'll be expecting to see it in standard form. So this will be 9x to the 5th minus 7x cubed minus 4x squared plus 11x, because this is a positive 11. So technically there's a plus in front. So this is our standard form right here. It's beautiful. We have to plug in that -1, and you can do that in the calculator and get your final answer. Again, just make sure you use parentheses any place you plug in a -1. When you're typing into your calculator, I'm going to put it up at the top. But when you type into the calculator, it should say -5 or 5, that's funny, negative 9 times, parenthesis, negative 1, parenthesis, to the 5th power. So notice the 5 is not inside of the parentheses, it's outside. Please make sure you're extra careful on that. And then also, please make sure you're using the correct negative sign. And in fact, I'm going to do a different color for the negatives. So if it's in blue, it's going to be a negative in the calculator, okay? If it is just a minus, I'm going to keep it blue. And I'll do that in a little bit different color blue, so it's a little bit more obvious. All right, so this is negative 7, negative 1 to the 3rd power, minus 4 times negative 1 to the 2nd power, plus 11 times negative 1. Okay, so I'm going to go back and make sure that all my minus signs are the correct symbol, and then all of the negative signs are the correct symbol. So remember, the red minus sign is really the negative sign. So on your calculator, it's the button below 3. And then the sort of aqua color, that is going to be just a normal operation, the normal minus sign, which is under the multiplication symbol. So take a couple seconds and type that into your calculator to figure out what it equals. All right, once you type it in, you should actually get an answer of 1. That should be your final answer. So please make sure you got that. So it's not any more difficult than the addition. I just chose a longer problem for this one, so it might seem like subtraction is a little bit more difficult, but I promise you it's not. It's just a little bit more work because now we have to deal with a trinomial as opposed to the monomial we dealt with in the previous examples. So I think that's it for that. Let's try multiplication, and that'll be the final thing that you need for this piece, and then you can work on your notes. So multiplication is the same idea. Again, I just want to show you how they write it. They take this, which I think, again, is very straightforward, and they write it like this, which to me looks a little wonky. I think they should have like a little multiplication symbol or a little dot between the F and G, but they don't, so whatever. They wrote the book, not me. But I just want you to be aware of what it looks like in the textbook so you're not confused and saying to yourself, well, I wasn't taught this. You were, I promise. All right, so we have multiplication, and with these, the trinomials will not be in this section because multiplying 2 trinomials together is a lot of work. So and if they do have a question like that, I would not make you do that because I think that's rude. All right, so here we have our 2 pieces. We have f of x equals x squared and g of x equals the square root of x. Find f times g, and then evaluate when x equals 9. All right, so for this one, I'm going to go ahead and I'm going to change this into exponential form. So remember, it's the square root, okay, and a square root technically has a 2 as the index. So if I'm multiplying f of x and g of x, all right, f of x is going to be x squared, and g of x is going to be x to the 1/2 power. All right, now that I've done that, I need to combine my my variables, okay? And so they said from section 5.1 that we were allowed to do this if the bases were the same. So in this case, the bases are the same. So I can take these and combine them, and when the bases are the same, we are going to add. So this is 2 plus 1/2, but you can't really, you can't have a mixed number as a fraction, or as an exponent, excuse me. So we are going to just turn this into a fraction. You can do this one of 2 ways. You can type into the calculator, press math, and then press the little arrow to the fraction. It'll turn it into an improper fraction, which you're allowed to have. Or you can just remember what you were taught in like elementary, which is we put this over 1, and we need the same denominator as the other fraction, which is 2. So I'm going to multiply the top and the bottom by 2. So I get 4 over 2 plus 1 over 2. Since we're adding, the denominators don't change, but the numerators do. So it'd be x to the 5 over 2 power. So this is our combined function. This is, our operation has been finished. Now we're going to plug in the 9. So really what we're going to type into the calculator is 9 to the 5/2 power. And again, you can do this a couple of ways. You can look at it separately, because remember we practiced this a whole bunch in 5-1. We could take the square root of 9, and then we can raise it to the 5th power, or you can type it to the calculator. I don't really care. Eventually, this is going to give you 3 to the 5th power, which is going to be 243, and that's your answer. All right, so same sort of idea, but again, it can be a little confusing just because it's new, so let's try one final one. Or actually, we'll do 2 more examples. Example 3.1a, same exact idea. We have the f of x times g of x, which is going to be 3 times the square root of x times negative 10 times the square root of x. All right, so I'm going to just multiply the things that are similar. 3 times negative 10 gives me negative 30, and then the square root of x times the square root of x, well, this is the same thing as when we had like the square root of 2 times the square root of 2. The square root of 2 times the square root of 2 is the square root of 4, which equals 2. So really whatever your base is, if it's the same, it just comes down, and that's your answer. So now I have the square root of x times the square root of x, which is going to give me the square root of x squared. And this is squared. So really my answer is just going to be x. So this is going to become x right here. And so now it's completely combined, and the final thing I need to do is just plug in that negative 4. So negative 30 times 4. You guys should be able to do this in your head. If not, I should be silently judging you, but I'm in another city right now. So your answer will be negative 120. All right, final example, and then I'll let you guys work on your notes, and that is example 3.2a. Same sort of idea, just wanted to deal with what happens, again, if your numerator, or not your numerator, your exponents are different. So f of x times g of x, so 4x times negative 2 x to the 1/2 power. And just to make sure that I'm understanding things and I'm not making any mistakes, I'm just going to go ahead and write the exponent of 4x over here, which is going to be to the 1st power. All right, I'm going to multiply the 2 things I do know, like 4 times negative 2, that's going to give me negative 8. And then x, and I'm just going to write it over here just so that I'm making sure I don't make any mistakes. X to the 1st power times x to the 1/2, same process as before. I need to add them. x1 plus 1/2. I can change this fraction, or this number, into 1 over 1, or really 2 over 2. I need the same denominator. Again, you could type this into your calculator, 1 plus 1/2, and then press equals, and then math, and then fraction. It'll give you the exact same thing. But long ways is going to be x to the 3/2 power. So I'll bring that over here. So this is my final combined function. Now they tell me to plug in the 4. So it'd be negative 8 times 4 to the 3/2 power. If you do it in your head, you can think about it as the square root of 4, which is 2. 2 to the 3rd power, which is 8. So your final answer will be negative 64, because negative 8 times 8 is going to be negative 64. Okay, again, you can just type into the calculator 4 to the power of 3/2, and again, it gives you 8. And then you just multiply it with the coefficient in front. All right, so that is that. Not super difficult. the sub should have a answer key for anybody who wants to double check their work and stuff. But I hope that helped a lot, and good luck. You guys will do awesome. And if you have any troubles, just text me and remind.